Hello everyone, and welcome back. If you're watching this on YouTube, I hope you're enjoying your break. If you're not and you're watching this in class, then I hope you had a great break. We're going to start off with a little bit of review of what we did right before we went on break, which is solving using the nth roots. So what I want you to do for this first problem is solve for x. I recommend that you guys use your notes, or at least focus on the steps of SATMEP. Okay, for the first one, you should have started off with your subtraction addition, which was to get rid of that 36 on both sides. There was no division multiplication in this problem, so you skipped right into the exponent. You saw that you had a power of 6, so the opposite of an exponent is taking it to the nth root, so a radical raised to the nth root. So you took it to the 6th root. That left you with x, and the 6th root is 64. If you did your factor tree, wrote it into a prime factorization to get a group of 6, would have been x is equal to 2. So go ahead and solve this second problem now using the same steps. Okay, with that one, you should have started with the 4th root on both sides. When you use a factor tree on 256, write it into its prime factorization, take out groups of 4, you should have gotten 2 times 2, which is 4. And then you add 5 to both sides, and you should have gotten x is equal to 9. Go ahead and do our last warm-up question. Okay, for that last warm-up problem, you should have gotten 3. We start with any subtraction addition, which is what we did. We did division multiplication by getting rid of that 2. It left us with x to the power of 5, which we could then focus on our exponent. So remember, when something is raised to a power of anything, to cancel that out, you take it to the nth root of that same number. So this is x to the power of 5, so you take it to the 5th root, and that cancels it out and leaves us with just the x. So we would get x is equal to the 5th root of 243, which is 3. What we are going to do now is work on problems that are similar, but are set up just a little bit different. Let's look at 2 times the square root of x plus 1 is equal to 4. For this problem, we want to use similar steps as SATMEP, but I am going to change it up just a little. For this, I am going to use SATMEP. So subtraction, addition, division, multiplication, that one will stay the same. The exponent will also stay the same, but what I want to also look at and group with that is a radical. Since subtraction, addition are opposites of one another, division, multiplication are opposites of one another, I wanted to also include the opposite of an exponent, which is to raise it to a radical to an nth root. And then again, the last thing would just be a parenthesis. So let's look at this first problem. I want to start off with any subtraction addition that I see. Well, I see a plus 1, but just like in this example, I couldn't do the minus 5 because that was inside of a parenthesis. I can't do the plus 1 here because it's inside of a radical, and that step is all the way back here. Next, I'm going to look for division multiplication. So I see that I have that number out up front. So to get rid of that multiplication, I am going to divide both sides by 2. That is going to leave me with the square root of x plus 1 is equal to 4 divided by 2, which is 2. Now to get rid of a square root, I have to do the opposite, which is square it. And what I do on one side, I do on the other. In these examples, when I wanted to get rid of an exponent, I used a radical to the nth root. In this case, to get rid of a radical to an nth root, I have to use exponents. So they're just opposites of one another, and I am left with x plus 1 is equal to 2 squared is 4. Sorry, subtract 1 to both sides. And I would get 3. I should get x is equal to 3. Alright, so here's our next example. I want you to go ahead and work on this one up until the step where you get rid of the radical. What do you get? Okay, so I asked you to work up until this point when you got rid of the radical, meaning there's no more radical in your problem. I started off by getting rid of the 1, then I wanted to get rid of the third root, so I raised it to the power of 3. Now it's left with 2x minus 9 is equal to 27. From here, you should be able to go ahead and finish the problem. Okay, you should have gotten x is equal to 18. Okay, so here are 2 more examples that I want you to work on. For the first one, you should have gotten negative 21. And for the second, you should have gotten x is equal to 27. Okay, with these next 2 problems, I want to address common mistakes that I suspect may be happening with these. So go ahead and get started with the first one. Okay, for the first one, you should have gotten 117. The mistake that I suspected that may have happened here is in this part right here. You might have gotten negative 11, and you might have known that you had to square it. But when you look at negative 11 squared, you're actually looking at negative 11 times negative 11. So what I see a lot of happening in this step sometimes is that students would then write a negative 121. When you multiply a negative and a negative, you get a positive. So this is actually a positive 121 because the negatives cancel each other out. So then when you subtract the 4, you would get the 117. So when solving these, be careful with that. Make sure that you know when the negative cancels out and when it doesn't. So from here, go ahead and work on the next problem, please. Okay, and here is that second one. So a mistake that I see is that sometimes we are just wanting to always make it positive. So you'll see that you end up with a negative 5, that when you take it to the power of 3, I am claiming that you get negative 125. So if I were to expand this off to the side, this is negative 5 times negative 5 times negative 5. So negative 5 times negative 5 would give me a positive 25. But then I would multiply that by a negative, and a positive times a negative would give me this negative sign right here. So that when I divide it by a positive, my answer should be negative at the end. So be careful of those little mistakes. Okay, these are going to be the last 2 of the day. Please solve these using SATMERP. Okay, and for the last 2, you should have gotten 88 and 5. So remember, if you want additional problems, practice problems on this, I recommend you look at Solving Radical Equations in your book, chapter 5.4, and it will give you more examples like what we did today.